everybody. Our project is on the case study of the poker game Texas Hold'em, and we'll start by introducing the background of our game. As one of the most popular card games of poker, it is very commonly seen in casinos worldwide, and the birthplace of the game is in Robston, Texas, back in the early 1900s. And it is officially recognized by the Texas legislature. It was first introduced to Las Vegas in 1963 and quickly became very popular and spread to many other places around the world. The game usually contains 2 to 10 players, and they can join the game into making decisions between raise, call, check, and fold. Many people consider the game to be played strategically because the players have multiple chances to bet, which includes a blind bet, and at the point after the dealer reveals the third, the fourth, and the fifth card. As Crandall Addington said, this game is considered as a thinking man's game. So at the start of each game, every player is handed with 2 cards that only they can see, and then the dealer is to place 5 more cards onto the table, which is known as the public cards, and showing 3 of them first. After the players review the cards on the table and the cards in their hands, they are to decide whether to raise or check, which is to let the dealer show another card. If one player decides to raise, then the other player must decide to call or to fold. To call is that they will place the same amount of chips into the pool as the previous player did to be ordered to see the card. And to fold meaning that they automatically lose the game. And this process is to be repeated 3 times in one game. The winning hand is determined by putting up together the best combination of 5 cards possible with the cards in your hand on the table. This table beside will show the ranking of the card values. And we are also going to introduce this concept of GTO, which stands for Game Theory Optimal. About 10 years ago, some of the players began to relate Texas Hold'em with a concept called GTO, which is to use mathematical method to make one's decision the most optimal. And this also divides the players into 2 parties. One supports the GTO and the other supports the exploitative play. In poker, GTO can be seen as a balancing method that prevents players to exploit the opponent's weakness, nor for their own weaknesses to be exploited. It is almost like playing rock, paper, scissors. If a player spends about a third of the time choosing rock or paper or scissors, then it would be impossible for the opponents to predict their actions, and by adding this, uncertainty complicates the game. Due to the introduction of GTO, players can't just look at their own hands and base their belief entirely on it, but rather they need to compare the expected utilities of each decision and choose the strategy with the best expected utility. For example, if a player is to get the hands of AA at the start of the game, and it would be obvious to see that the expected utility of raising is greater than folding. So if this is a rational player, they would always raise in this situation than to fold. When the expected utility of a action are the same, then that is when mixed strategies come into play. Speaking of exploitative play, it is rather an unbalanced method. It is used to exploit the opponent's weaknesses, and your weaknesses also have the chances of being used by the opponent. This comes in play when you are familiar with your opponent's playing history. Hence, if you observe that player A is a weak player, then you will use the method bluffing more often and raise to scare off player A, even if you have a small chance of winning. If, for example, you observe that player B always chooses to call in the game, then you wouldn't choose the bluffing method and raise the bet, noting that they will always call no matter what. And in poker, we call these players calling stations. Hence, there is no optimal play in the exploitative play because our decisions are always based on our knowledge of the opponents, and that is why more psychological elements are introduced. And this raises another question: why don't we use both of them? In fact, both concepts are really useful tools which we can use to help us make the best decisions. For example, GTO can be used when calculating the pot odds, the probability of a certain hand, your expected utility based on your beliefs, and so on. While exploitative play can be used in determining your opponent's moves and how believable a bluff is, and so on. Next, we will show two specific examples of the game, and this will be demonstrated in order to help with the comprehension of the rules. So first, here we have two players, and player 1 gets 5 of hearts and 6 of hearts for the first two cards, while player 2 gets 9 of spade and 9 of clubs. According to the judge's prediction, player 2 has a higher probability of winning, which is at 78%, while player 1 is a little unlucky. Then, after seeing the two cards, player 1 bets 10 chips after, and player 2 follows by also betting 10 chips into the pool. And then the dealer places 3 more cards which are viewable to both players at the same time. They are 7 of hearts, Ace of spade, and 2 of spade. We can see that the player 2's probability of winning rises to 91%, which means it is almost impossible for player 1 to win the game. But however, at this time, both players chooses to check, which means that none of them chooses to add more chips. While player 1 still doesn't quit, the dealer passes out the fourth public card, which is the Ace of Hearts, and at this time, player 2's winning probability rises to 100%, which means that it is definitely impossible for player 1 to win this game, except if player 2 decides to fold. And expectedly, player 1 quits the game by choosing to fold. The final result is that player 2 wins the 10 chips and player 1 loses 10 chips. We can create some assumptions here. For example, what if player 1 believes that he must have the better cards due to player 2's conservative behaviors? He may continue adding card chips, and as the absolute winner, player 2 will always keep up, and in the end, player 1 will lose anyway. But he will lose by more than 10 chips. What if another situation where player 2, after seeing his cards in the first round, is extremely confident in winning this game, and he chooses to rise the bet like higher than 10 chips at the very beginning of the game? Will player 1 keep up, or will he be frightened by this movement and give up early? These questions require our analysis. The second game is even more dramatic. Player 1 gets Ace of Heart and Ace of Diamond, while player 2 gets King of Diamond and King of Spade. Although player 2's cards are great if we look at them separately, it is not easy for him to win since his opponent is even better. This gives player 1 a winning probability of 82%, which is way higher than player 2's. Both player chooses to raise and gives in 10 chips at the first round, and then the dealer passes out 3 cards, which is Ace of Heart, 9 of Diamond, and 7 of Hearts. Player 2 seems really confident in himself, although he is not likely to win this game according to the jury's prediction. And he decides to raise 100 chips, and as his opponent, player 1 has to follow. In the next round, the dealer passes out a 4th card, which is 10 of clubs, and interestingly, player 1, the one who have a better hand, chooses to check and passes the option to player 2. Player 2 becomes even more self-assured, and he's more confident than usual. He throws in 180 chips, which is a really large number, and player 1 decides to follow again. When the dealer hands out the last card, which is the Spade of 4th, player 1 knows that he is going to win absolutely, and however, he still chooses to check. But player 2 realized that there might be something wrong, so he chose to check, refusing to get into player 1's potential trap. But it's too late. The game ends with player 1 earning 375 chips and player 2 losing almost all of his chips. But what if player 2 chooses a safer strategy from the beginning of the game? And what if he didn't add 180 chips but chose to watch till the end? What if he avoided player 1's conspiracy earlier? These are questions to be considered. And from these 2 examples, we can conclude some prediction about people's internal thinking. Why will people choose to check even when their probability of winning is high? Firstly, it may be just simply because they are not confident enough in their cards and their chips are not at an optimistic amount. And secondly, it may be due to their own suspicions. Both players are not sure about their opponent's true condition, and they don't know whether they are holding a better hand or not. And lastly, it is a type of strategy to show your opponent that you are not getting good cards, but in fact you know you are going to win. You disguise yourself and letting the opponent gaining more confidence and adding more chips into the game. This strategy is called lure. And next, what can one player do if his probability of winning drops to 0%? And this means that it is impossible for him to win the game. His first choice, also the risky one, is to continue adding bets as if he can win 100%. If your opponent's cards are not that good, this kind of behavior will more likely cause the opponent to fold. But it really depends on one's luckiness and the opponent's psychological enduring capacity. Secondly, if one chooses to stop right away to prevent any further lose, and they didn't add too many chips into the game, this would also be a great choice. After viewing the two cases, we are going to model Texas Hold'em as a unique, strategic, sequential game. Common Texas Hold'em can accept 2 to 10 players in one game, but for our model, there will only be 2 players. Strategy is basically choosing the right action to do after analyzing the opponent's behavior, raise or call the appropriate amount of chips, or just draw out at the right time. All the basic rules from the common Texas Hold'em applies to the game. First, 2 players are both handed with 2 cards that only they can see, and there will be 5 additional cards face down in the middle, known as the public card. 3 cards will be shown at the beginning of the round 2, and then 1 card will be shown each round after. Player should choose between raise or call, check, and fold. If a player chooses to raise, the other player only has the option of call or fold. If player chose to fold, the other player wins automatically. The outcome and the payoff of the game will be defined as follows. Both players share the same utility, which means that we assume that there won't be a situation where one player treats these chips more valuable than the other player. If one player wins, he will value the winning as 5 times the chips he earned. And on the other hand, if he loses, he will value the lose as negative 5 times the chip he lost. Additionally, if one player decides to fold after he shows his card, the dealer finds out that he actually had the bigger hand. A negative 5 utility will be added to him, while his opponent will be rewarded a 5 utility for successful bluffing.
Then we are going to discuss the belief of this game. There are 4 possible beliefs for Texas Hold'em, and we are going to assume that players are rational and always seek for maximized profit. First, player 1 believes that player 2 has better cards. Player 1 will stop calling at once, or player 1 will choose to add a small amount of chips each time, or player 1 will choose to check. If player 2 continues adding a large number, player 1 will withdraw, since he is a rational being. But player 1 will also choose to bluff player 2 by adding a lot of chips, also known as the risky strategy. If player 1's belief is correct, since player 1 withdraws at a timely timing, he only loses a small amount of chips. And if player 2 withdraws too late, he will lose some chips. Player 1 may successfully bluff player 2 and win the game surprisingly, also get a 5 utility prize for his bluff. Or, the worst result is player 1 fails to bluff player 2 and lose everything. But what if This belief is incorrect. Player 1 withdraws and finds that player 2 actually has two worse cards. He loses the chips he added into the game before and also gets a 5 utility penalty for wrong judgment. Or player 1 wins the game surprisingly, but realizing that he missed a chance of earning more. Or player 1 may believe that player 2 has worse card. By thinking of that, player 1 will keep adding chips every round, or he will choose to check in order to confuse player 2. Player 1 will also add a lot of chips immediately in one round due to his confidence. If his belief is correct, player 1 will win the game and gain a small amount of chips due to player 2's early fold. Player 1 will win a lot of money due to his great disguise. But if the belief is incorrect, player 1 will win the game and get a 5 utility prize due to player 2's early fold and false judgment. Player 1 will maybe lose a lot of chips due to his false confidence. Or the third belief will be player 1 may believe that player 2 will have a better combination later. Player 1 will then keep adding a small amount of chips each round, hoping that there will be the turning point later. Player 1 may choose to check in order to prevent any extra loss. Player 1 may choose to add a large amount of chips in order to confuse player 2, or player 1 will choose to give up as soon as possible. If the belief is correct, player 1 will lose some chips because of his adding for each round. Player 1 may lose a large amount of chips due to his failed bluff, or player 1 may win due to his successful bluff plus a 5 utility prize. Player 1 may also lose a small amount of chips because of his early withdrawal. However, if player 1's belief is incorrect, player 1 may only earn a small amount of chips due to his safety strategy. Player 1 may earn a large amount of chips due to player 2's insistence. Player 1 may earn some chips due to player 2's early fold and a 5 utility prize. Or player 1 will lose the game and get a 5 utility penalty for false belief. And the last belief is player 1 believes that player 2 will have a worse combination later. Player 1 may keep adding a small amount of chips each round. Player 1 may choose to check to wait for more information and then add a large amount of chips in the last round. Or player 1 will add a large amount immediately. If the belief is correct, player 1 will earn some chips, or player 1 will earn a large amount due to player 2's insistence. Player 1 may earn a small amount due to player 2's early withdrawal. If the belief is incorrect, player 1 will lose some chips due to his adding each round, or player 1 will win the game and get a 5 utility prize due to player 2's withdrawal, or player 1 will lose a large amount due to his false confidence. We also think that there are two signals in Texas Hold'em. The first one is when people chooses to check. It signifies that this player is not confident with his cards, or player does not get good cards at the beginning of the game. However, we don't think that this sign has high credibility, since players can still add chip till the very end of the game, so it costs nothing to pretend and disguise oneself by checking. The next signal is adding a lot of chips, like all in, which means adding all you have into the game. It signifies that player is confident with his cards or player gets great cards. This signal has high credibility due to its high cost. The credibility and amount of chips added has a positive relationship, which means the more chips added, the more credible the sign is. Lastly, we're going to introduce another new concept called Kelly criterion. Kelly criterion is a very famous formula for game theory, also known as scientific gambling method. It is mainly used for determining the most appropriate bets or capital in games for games or investments. It is first used for the strategy game like roulette. Its formula is F equals to bracket B times minus Q bracket and all over B. In the formula, F equals to the best amount of percentage of your money for betting and B in our model equals to 5, meaning that winning one chips equals to 5 utility. P is the percentage of winning and Q is the percentage of losing, knowing that we assume that P plus Q is always equal to 1. A simple example is if a player has a 60% probability of winning the game and B equals to 1, what is the suitable percentage for this player to bet? And it is easy to get that F equals to 20%, which means player should bet 20% of what he has in the game. Before we wrap up, we create an open question for the audience to consider. Imagine that there is a new type of game called Limit Texas Hold'em. In this game, the player can only raise the bet when all the cards on the table are shown. But before any card is shown, one of the players must bet 10 chips, which is called blind bet. Player will take turn to do the blind bet. There will still be 2 players, payoff ratio will be 1. The objective of both players are to win the game and they value winning and losing at the same utility. So how will players' beliefs and choices from limited Texas Hold'em different from the players from the Texas Hold'em we've discussed about? So after listening to our speech, our audience should know that the poker game Texas Hold'em is a highly strategic game and it's very difficult to model and solve. It is a game of imperfect information. After our presentation, our audience should be able to explain the rules of the game and the strategy players may play. Our audience should also be able to read the signals and understand the beliefs. And lastly, it is also important to under the Kelly criteria. Thank you, and that's all of our presentation.